We are working through chapter 8-8b, the area of circles and irregular figures. And this set of irregular figures will contain either circles or semicircles. We have only one formula for the area of a circle, and that is A equals pi r squared. Notice that the formula does say r, therefore you must have the radius. If in the diagram or in words they tell you what the diameter is, you will need to divide it by 2 before using it in the formula. And in this first part they are going to tell us to use 3.14 for pi. And note that we are supposed to round our answers off to the nearest tenth. We will start with the formula, area equals pi r squared. Pi is supposed to be 3.14. Look at the diagram. They give us the radius, so I can use 11. Now, some people will say 11 and then use the exponent of squared. And then on their calculator, they'll use their x squared key to use this. I have a tendency to just put it in there twice. It's just as easy for me to do that. And since we will be rounding off, we will use approximations. And when you put that through a calculator, you should get 379.9. They do give me the unit of measure here. We're back to area, so that means I have to use square units. In our next example, first of all, you got to take a good look. Okay, that is a diameter. So even if I use my formula of pi r squared, I'm going to have to divide the 15 by 2. They want me to use 3.14. The diameter is 15, so the radius is 7.5. And putting that through a calculator, I will have 176.6 feet squared. And I would suggest that you hit pause and try that yourself. However, the next two, the diameter of 16 and the radius of 6.6, I want you to hit pause and do those two on your own. And at this point, you can check out the last two problems on this first part of our lesson. In the second part of our lesson, we are going to work with irregular figures. Again, just as before, divide it up into known figures. Look for parallelograms, rectangles, circles, half circles, triangles. Look at your flashcards to see where your formulas are. Find the area of each part, and then you're going to have to decide if you need addition to find the desired area or subtraction. In our first example here, we are going to be finding the total area. Now, when I look at this particular diagram, I see a triangle on my left, and I see a parallelogram on my right. So the first thing I'm going to do, just give myself some more space, but I'm going to find the area of the triangle. 1/2 BH, 1/2. I'm going to take the base as 12 and the height as 15, because note here's that right angle. That would mean 6 times 15, which is going to be 90. And again, note that I put a label here too. Now on the right side, I actually have a parallelogram. So this is going to force you to review those formulas that we used a couple of lessons ago. And here's that right angle. So my base is going to be 15 and my height is going to be 10. So the area here is 150 centimeters squared. Now, I want the total area, the complete area. I have to decide if I need addition or subtraction. Well, I have to add the triangle and the parallelogram. So the total area here is going to have to be 90 plus 150. Only a 1 there, sorry about that. 240 centimeters squared, and that's actually my total area. They don't really tell you, but when they show you a diagram like this, I didn't put the directions here, but generally in your book, they're going to say find the area of the shaded portion or find the area of the shaded part of the diagram. So when I look at the diagram, I first of all see, all right, there's a big square there, 25 by 25, and then they're going to take that 9-foot circle, 9-foot radius circle. Now, it almost looks like that they're cutting, probably cutting, to me it looks like a bolt, the nut on a bolt, and I'm going to cut the hole out. What this probably is, could actually be, is an irrigation on a field of some sort or something, or maybe you're going to tie the dog in the center of the yard, and how much area will you have where you probably don't have to use your pooper scooper. So I look at the one area and I see a square. So I'm going to use area equals base times height. 25 times 25, and my area is going to be 625 feet squared. I have the circle. Well, the circle is pi r squared, so I'm going to use 3.14. My radius is 9. And I'm not going to round this one off, actually, since it will come out pretty evenly at 254.34. Again, feet squared. Now, I want to find the shaded portion. I'm going to have to subtract, because literally what I'm going to do is pull that circle out of the square. So I'm going to take 625 minus 254.34, and I will get 370.668 squared. This is an irregular figure with a semicircle. Now, it's kind of nice. I can actually kind of make up my own formula. A semicircle is half a circle. So I just take the area for a circle and I stick a half in there. Pi r squared. So I'm going to have 1/2, 3.14. Now remember, that 15 is diameter, so you have to put in 7.5. And I get 88.3125 meters squared. Now I have a trapezoid. Maybe I better work over here instead. Might be easier for you to see it if I can keep the diagram. This part here is a trapezoid. So I'm back to that 1/2 the sum of the bases times the height. Remember we said that sometimes your trapezoid is kind of lying sideways? So my B1 is going to be 30 and my B2 is going to be, B sub 2 is going to be 15. Because my bases are here and here, generally we go left is B sub 1, right is B sub 2. The height is going to be 10. When I put that into a calculator, I will end up with an area of 225 meters squared. Again, hit pause, do it yourself so that you know what's coming. All right, now find the total. Well, this is pretty much like our first example. I'm going to have to add them. So I'm going to take 225 plus 88.3125. Since they haven't told me to round off, I'm just going to keep it all and go 3125, and that will be meters squared. My last example, they tell me what the radius of the large circle is, that's the shaded one, and if that were all complete, and then the radius of each small circle is 5 feet. They want me to find out what's the shaded area once I take out the circles. Okay? So I'm going to do the large circle first. It is pi r squared, 3.14, and I'm going to go with 28 times 28. Now when I put that into a calculator, this time I'm going to round it off a little bit, and I'm going to get, I might not have to, but I'm going to get 246.3.0 feet squared. Now, I've got the small circle. One small circle is pi r squared, 78.14, and they tell me that the radius is 5. When I put that into a calculator, I'm going to get 78.5 feet squared. There are 5 circles. So I'm going to take 5 times 78.5, and that's going to equal 392.5 feet squared. And this is a shaded one, so obviously you're probably going to subtract. You're going to have to take all 5 circles out. So I'm going to take the 2463.0 minus this 392.5, and I'll find that my shaded area is 2070.5 feet squared. And that completes lesson 8.8b. This time, please reply with apricots. Scouting out.